So in this video I want to talk about the divisor function. The divisor function is d of n, and d of n denotes the number of positive divisors of n. And I can express that in summation notation by the notation sum over all the divisors m of the integer n, and each time I have a divisor of n, I just add 1 to it. And in this case, the divisor function is an arithmetic function, which I discussed a couple of videos ago, and an arithmetic function is basically any function which maps a natural number to a complex number. And in this case, the divisor function happens to be an arithmetic function. It's also a multiplicative function, which I'll prove somewhere down the line. Now, before, what we used to do when calculating d of n for certain values of n is we used to go through every value of m individually until we found a divisor, and then we added 1 to d of n. But that can prove to be quite long, especially if n happens to be quite a large number. So for instance, if n were 400, you wouldn't really want to have to try all the numbers from 1 to 400 to try and find what d of 400 is. So there are some shortcuts. So first of all, if we know the prime factorization of the number, then we can use a little shortcut. So in this case, if n has prime factorization p1 to the power u1 times p2 to the power u2 times pr to the power ur. Now in this case, p1 represents a prime number, p2 represents a prime number, and all of these p's up to pr represent prime numbers, u1, u2, and ur, and all the ones in between represent the powers of these prime numbers. So in this case, n could be 2 to the power 3 times 3 to the power 2, and in that case, p1 would be 2, p2 would be 3, and the powers of 2 would be u1, which is 3, and the power of 3 would be u2, which is 2. And if that's the case, if n is this product of prime numbers, then we can say that d of n is just 1 plus the first power times 1 plus the second power, and we keep doing this until we reach the last power and do 1 plus u sub r. And that's quite a nice way of saving some time. So let's look at a few examples of this in action. So the first example asks us to calculate d of 450. What is the number of positive divisors of this number? Well, I don't want to have to try and look at all the divisors from 1 to 450 individually, so what I'm going to do instead is just try and find the prime factorization of 450. So let's do that. 450. Well, immediately I can see that 450 is 45 times 10, so that's 45 times 10. And can I break this down some more? Yep. Well, 45 is a multiple of 9. I know that 45 is 9 times 5, so I can replace 45 with 9 times 5. And that's being multiplied by 10, and I know that 10 is 2 times 5. Okay, I'm just breaking it down into the product of prime factors. And what next? Well, I know that 9 is 3 squared, so I can replace 9 with 3 squared. Times 5 times 2 times 5, so everything else remains the same. And what's the prime factorization I get? Well, I've got just one 2 term, so that's just going to be 2. I've got 3 to the power 2, so that's going to be times 3 squared. And I've got 2 5 terms appearing, so that's going to be times 5 all squared. So now I can use this to find the value of d 450. So what's that? What's d of 450? So therefore, d of 450 is what? Well, in this case, my p1 term is 2, and my u1 term is 1, because the power of 2 is just 1. And the first product is going to be, well, the first term in the product is going to be 1 plus u1, but u1 in this case is 1, so that's going to be 1. Then I've got to multiply that by 1 plus u2. So 1 plus u2. u2 in this case is 2, because it's 3 to the power 2. So that's just 1 plus 2. And then I've got 5 squared. So in this case, p3 equals 5, and u3 equals 2. And 1 plus 2 is 3. So 1 plus u3 is this thing. And when I do that, what do we get? Let's just give it some space here. So when we do this, we get 2, that's 1 plus 1, times 3, that's 1 plus 2, times 3, because that's 1 plus 2. And 2 times 3 is 6, times 3, and 6 times 3 is 18. Okay, so the number of divisors of 450 happens to be 18 in this case. So just to recap, here's what we did. So we wanted to calculate d of 450, and we used this value as u1, because that was the term appearing as the power of 2 here. And then we wrote down 1 plus u2, and this was our value of u2. It was the power of 3 appearing here. And this was our value for u3, because this was the power of 5. And it's worth noting that you don't have to look at all the prime numbers individually. So for instance, if this said 2 times 3 squared times 7 squared, even though we skipped out 5, we wouldn't actually count it anyway, because 5 doesn't appear. So we can just sort of forget about it and move on to the next prime. And in any case, we end up having 1 plus 0, so it doesn't really matter. So let's move on to the next example. Let's calculate d of 76, and we can use exactly the same technique. We know that 76, well, that looks like 4 times, well, let's do like this, 2 times 38, just halving it. And 38 is 2 times 19, so that's 2 times 2 times 19. And that's 2 squared times 19. So that's the prime factorization of 76. So let's look at this. This is my P1, so P1 equals 2. And this is my value of U1. And my P2 in this case is 19. And U2 in this case, well, the power of 19 here is 1. So I can sort of think of that as being 19 to the power of 1. So that's my value of U2. So using this, I get d of 76. That's equal to 1 plus u1 times 1 plus u2. And that's just, what, 1 plus 2 times 1 plus 1. And that gives me 3, because that's 1 plus 2, times 2, because that's 1 plus 1. And that gives me 6. So the number of divisors of 76 is 6. So that's all that's in this video today. Thank you for watching. In the next video, I'm going to look at how we actually derive this formula. So earlier in the video, I said that d of n is the product of all of these terms, and we're going to look at how we actually prove this. And eventually, we're going to look at some more complicated formulae for other sum divisor functions. Thanks for watching.